we're going to talk about computing limits of composite functions. So if I have the limit of g as x goes to c is L, and then if I also know that the limit as x goes to L of some other function is the same thing as f of L, then when I take a composite here, f of g of x, you can essentially bypass the outside function and just compute the limit inside, and then plug in the result into the f function. So let's look at an example here of how to use this. I know that rule is written generally, it's kind of hard to see. Let's say I want to compute the limit as x goes to 0 of the square root of x squared plus 4. This function here is a composite function. It has an outside function, the square root, and it has an inside function, x squared plus 4. And so when you're computing this limit, what we can do is we can skip over the square root and look at the limit of the inside. Well, now I'm looking at the limit of a polynomial, which I know from previous videos we can just plug in x equals 0 into that polynomial there. So this is the square root of 0 squared plus 4, square root of 4, which is 2. So when you have a composite function, you always have an inside and an outside function, and you're going to bypass this outside, in this case square root function, and then just compute the limit on the inside here. Alright, so now I want to mention some special functions. So we're going to look at, suppose that C is in the domain of the given function, and I can just evaluate the following limits. So sine of x, as long as x is in the domain, this would be sine of c. The same thing for cosine. You just evaluate cosine of c. Same thing for tangent, as long as c is in the domain of tangent. You can just plug in tangent of c. And then you have something for the remaining 3 trig functions. So cotangent would be cotangent of c. Again, as long as you're in the domain of the function, you can just evaluate. You have secant c, that should be an x there, sorry. And then you also have one for cosecant. So as long as you're in the domain for any of these 6 trig functions, as long as c is in the domain, you can just evaluate to find those limits. And you also have something kind of like that for exponents and the natural log. So the limit as x goes to c of a to the x would be a to the c as long as a is positive. And the limit as x goes to c of ln of x will be ln of c. So let's look at a few limits involving these kinds of functions. So let's compute the following limits. Let's start with the first one, the limit as x goes to 0, tangent of x. Now 0 is in the domain of tangent, so because of that I can just plug it in. This limit would be tangent of 0, which is 0. Okay, let's look at another one. The limit as x goes to -1. Here I have a product, so I can split this up using my properties. I can split this up as the limit as x goes to -1 of x. Comes the limit as x goes to -1 e to the x. Okay, split that up. This first one here, this is a polynomial, so you can just plug in your number, -1. And then this e to the x matches our exponent one from back here. So I can just plug in -1 in place of x. So this limit would be e to the negative first. And then there's my limit overall. And one final one. Let's compute the limit as x goes to e of ln of x cubed. Well, the first thing I can do is I can use my limit laws to bring down this exponent of 3. And then I can pull out this scalar out in front. So this would be 3, the limit as x goes to e, ln of x. And now I can use that this is a natural log, and I can, e is in the domain, so I can plug in natural log of e, which is 1, so this limit will just be 3.